Okay, so remember we have x1, y1, x2, y2, and you can put those in the other order if you want, but we need to do the y minus the y and the x minus the x and be consistent. So I'm going to do this y minus this y, so 49 minus 96. And at the bottom I'm going to do the second x minus the first x. We are subtracting a -3, so that means we're going to add in the denominator. Okay, so it's 49 minus 96. Okay, -47. And -11 plus 3. So a negative over a negative is a positive, and I do want you to make it a positive in that last step. Okay, we're going to go to the slope. Some good review. I don't know that we've actually learned the distance formula. We've used Pythagorean theorem. I'm not sure, but let's put this in the back of our notebook as well. So go ahead and turn to page 6, lengths, and I want you guys to write down the distance formula. So we can label them the same. This can be x1, y1, x2, y2. You don't have to label them. It just helps sometimes. Okay, so then we have d equals the square root of y2 minus y1. So 1 minus -2 squared. Always a plus in the middle. Okay, so minus signs in the formula, but a plus in the middle. So now we've got x2 minus x1. So -3 times 4 squared. Okay, so now I've got 3 squared here, so that would be 9. And I have -7 squared here. What's -7 times -7? Okay, positive 49. You should never have negatives after you square. Okay, never have any negatives. So now I've got 9 plus 49, and we get the square root of 58. If you can simplify, but 58 is 2 times what? 29. 29 is prime, so there's no double numbers or squares that come out of that, okay? Alright. Pressure. Anyone have a guess what the V is? Volume. Okay. And how about the T? Time. No. Yeah. Temperature. And N is new and R is new. So N is actually going to be moles. You guys done moles? Yeah. In like chemistry? And R is a constant, and this is something you're going to have to memorize. The book gives it to you the first couple times, but then you have to memorize it for the test. So R is equal to this lovely decimal right here, 0.0821. Alright, so you guys can flip back to the book and we'll solve this one. We'll try it. So use the relationship PV equals nRT to find the number of moles of a quantity of gas when the temperature is 159 kelvins, the pressure is 2 atmospheres, and the volume is 4 liters. They're telling you R. Begin by, solving the abstract equation for N. So just like the other equation when we did ideal gas law, we had to cross multiply and like solve for one variable. We're going to do the same thing here. Whichever one we're solving for, we're going to isolate first. So for this one, we're solving for moles, which is N. So we're going to divide both sides by RT. And then we have N by itself. Okay? So what am I going to plug in for P? 2. Pressure is 2. Okay. What are we going to plug in for V? volume is 4 liters. What are we going to plug in for R? Yeah, that decimal that you need to memorize, 0.0821. And what are we going to plug in for temperature? Yep, 159 kelvins. Okay. When you plug it into your calculator, again, make sure you have parentheses and then divided by, or if you have the Inspire, that's doing fraction. And anybody got that decimal for us? Max? Good. And since we're solving for n, we label moles. Okay. I want to review the vectors that are on the axis. I was having you guys use the degrees, and it's going to mess you up when we go down, because it double counts the negative. So I want you guys to start doing it without the degrees. So let me just show you how we would do that, and then we'll do a couple of them. So 5 that goes to the right. So if I'm doing this one right here, is that the I or the J that's being affected? Yeah, the X is the I, right? So this 5 right here would be a plus 5I. Is there any J? Does it move it all in the Y direction? No. So if we're on this axis, you would add nothing to the J and just 5 to the I. And then you don't have to do any degrees. Okay? You don't have to do a cosine or a sine either. You can just add 5I. Okay? And if we're going straight up, is this the I or the J? This is the J, and it's positive, so plus 5J, and you would add nothing to the I. Okay? And if we're over here on this axis, what do you think we're going to do instead of plus 5I? Yeah, minus 5I, because that one, again, I is the X. All right, and then this one was plus 5J, so what's the down one going to be? Okay, minus 5J. All right, and that's it. Then don't do cosine, sine, and don't plug in the angle, because that's going to double count the negative on the downward ones, which you might see later. So let's try one of these. So do write this down, guys. So we're going to add the vectors, and we've got the one that goes down, that's 7. All right, so first we've got our cosine direction, which is our I. So this one right here is going left. So we would have negative 6 cosine 30. Okay. This one that's going straight down, does it go in the I direction at all? No. So if you want to put plus 0, you can, or you can just put nothing, because we don't add anything for that second vector to the cosine. And now we've got the sine, so I'm going up right here to get to this point. So 6 sine 30. And then we're going down in the Y direction, which is the J. So what would I put? Minus 7. And that's all inside the J parentheses. Okay? And then you guys plug that in. And we could go back to polar. You guys want to review that, or are you good?